Hello, everyone. My name is Jacob. I'm with Spectral Cloud, and I work with a great team of engineers on the Kairos project. I've been in the Kubernetes space for about 3 years now, but most of that has been focused on edge solutions and edge tooling. So today we're going to kind of chat about Kairos, which is an immutable Linux operating system and edge factory. But before we get into that, I kind of want to just go over what is edge. Quick show of hands, how many people here know what edge computing is or have worked with it? Okay, good. Quite a few of you. Wonderful. So edge computing, when we think about it, is the computing. When you think about traditional like DevOps, you're working in data centers, cloud environments, and they solve a lot of problems for you because they have things like redundant power, redundant networking, tons of compute space. Edge computing is computing where these devices tend to be in areas that aren't optimized for computing. They're restaurants, vehicles, telco, all the cell towers, all kinds of locations. So with that brings its own unique challenges, right? You're going to have issues with reliability, a lot more hardware failures, unreliable networking, intermittent connectivity, all kinds of things. And with these edge devices, what we're typically seeing is a lot of sensor data collection, so recording real-time data and then either sending that back to a location or even analyzing it on site. You can also see it in user applications. So you may have a restaurant that their POS system, you want to manage that software, distribute updates. And so when we look at edge and kind of how we approach these problems, great solution for that is Kubernetes. Kubernetes can help with a lot of that kind of responding to environmental changes because you have the reconciliation. It also makes it easy to get up and running in edge environments because a lot of the applications that you're used to are already configured to be deployed with Kubernetes. So it can make it easier to get up and running, and it can also help with some of the scaling concerns because Kubernetes can manage multiple devices, help them coordinate. But with that scale comes its own challenges. So when we talk about edge environments, typically you can have upwards of thousands to tens of thousands of devices. And so you're going to need to manage all of those. You're going to need to provision all that hardware. You're going to need to set it up on site. And you're going to need to make sure you're doing that consistently. So we can't have in edge computing, you can't have the snowflakes. You can't have where you just shell in and quickly fix that deployment that went sideways because you may not be able to get a shell and you maybe have to do it 1,000 times. So edge needs to be reproducible, and you can't have any, you really want to avoid any customization per deployment. So the other challenges with the Kubernetes is how do you manage those day 2 operations? How do you manage your application, trigger updates on these sites? Security is another big concern, especially on edge, because it's not only, if you think traditional security in like a cloud environment where you're focused on firewalls and access, API controls and all that. In edge environments, I can walk in and grab a device and throw it in my pocket and then take it home and start scanning the drive. So security gets a little bit more complicated on the edge. You also have limited resources, so form factor and software footprint become important. You can't have, you're not going to have your 2 terabyte of RAM available. You might only have 4, and that's 4 for the OS, Kubernetes, and then whatever's left is for your applications. So need to be cognizant of that. And then the other thing is you're not always going to have technical experts on site to do these deployments. You may have non-technical users doing these deployments, consumers, and also sometimes even getting to these environments. Some of these are really remote sites, and so if something goes sideways and you need to get just any person on site, that might involve getting a pickup truck and driving, through the desert for a while. So what solutions do we currently have for these problems, right? There's K3s, which is a fantastic Kubernetes distribution. It solves that kind of form factor issue and the software footprint. It's a very compact distribution, but it doesn't do any management related to the operating system. So for that, you could look at something like Talos, Flatcar, Bottle Rocket, but they all have their own issues as well. Talos is very opinionated, so you're not going to be able to do, you're going to have to kind of do things their way, which might be difficult for migrating existing applications. Bottle Rocket cannot run control planes, so that means that you're going to have to, your devices need to be able to call home reliably, or you're going to have to find another solution to deploy your control planes. And then Flatcar is another, it's a great operating system, but you can only configure it through cloud configuration, so that can sometimes be problematic. K3OS, it was a great product, but it's not really being developed at the moment, and then that leads us to Kairos. So Kairos is we'll get into it in a bit more detail, but Kairos gives you the flexibility to kind of control. It's not opinionated as far as what operating systems you're using, and it's not going to box you into a specific set of tools. So it's a lot more flexibility, a lot more customization, while still getting you a lot of those advantages you need in Edge. So when we're evaluating solutions for Edge, what are we looking for? You want immutability. That goes back to the reproducibility across all the environments. I need to be able to simulate in a lab what's going to be simulated in the field easily, and I need as few failure points to that process as possible. Orchestration is a big factor of that because not only are you going to have to manage a lot of deployments, they're not all necessarily rolling out at once. So I've seen some use cases where you have devices, you'll provision them with some initial software from the manufacturer, and then they sit on a shelf for 6 months to 2 years before they're actually deployed to a site, and you don't know what site they're being deployed to. So you need a solid orchestration to be able to manage that and ensure that you're able to get those deployments out. Disk encryption, like we talked about, important for security because hardware is going to be accessible to some extent, so we need to make sure that anything on those devices we're going to be able to secure in the event they're compromised. OS customization is also going to be important. A lot of times we're going to be dealing with, we're going to require custom drivers, or we're going to have special hardware that we're interfacing with. So we really need to be able to modify that operating system. We need declarative configuration that's going to make our change management much easier. And it's going to make it, as we roll out updates and make these changes across all these environments, it's going to make it simple to understand what the differences between environments are. Extensibility is, again, just kind of the ability to add additional, not be boxed into specific set of tools, add whatever, applications or customizations you need, because especially with Edge deployments, you tend to have a lot more of those special cases as far as, disk layouts or all kinds of things. So you need to be able to accommodate that. And then lastly, you also want to consider, how well is it going to integrate with Kubernetes? So, can I manage my building these artifacts, or kind of manage these changes through Kubernetes? And then how am I deploying Kubernetes on top of this operating system? Because setting up Kubernetes from scratch is a bit involved at times. So you want to make sure that whatever tool you're using makes that process as simple and manageable as possible. So with that, let's talk about Kairos. So Kairos, opposed to some other tools, it's a meta distribution. So what that means is Kairos does not have a set package manager. It's not its own OS or Linux distribution. It's actually a layer you can put on top of other distributions. So going back to that customization aspect, like you can just take any Linux distribution Docker image and then use that as a base for Kairos to build out your your OS image. So Kairos, layering on top of those Linux distributions, Kairos introduces the immutability. So it's gonna allow you to have an immutable root file system. That's gonna make updates much easier. Installation is gonna be very consistent because you're not installing or making changes on site. Those changes are already just baked into the image. It's also going to give an agent for interfacing with these changes, so triggering modifications to the environment, triggering installation, all of that's going to be managed through the Kairos agent. And we'll get into more detail about how you interface with it. There's a couple different ways, but Kairos will all manage that at the core. And then most of the Linux distributions in their container images do not include the kernels and the initRD. So Kairos will take care of packaging those in and making sure that you can control that and modify those as needed. So that's kind of like the core functionality of Kairos. There's also a step further where we have Kairos standard. This introduces Kubernetes distributions. So by default, it uses K3s, but you can also use CNCF, RK2, whatever, any distribution you want to add. And it also introduces some tooling for automatically orchestrating these devices. So when you want to create a highly available cluster, you don't have to have all of that laid out from the beginning. Devices can actually find each other and coordinate a highly available cluster just by running on the same network. So talking about configuration with Kairos, this is one way to introduce configuration. There's actually a couple we'll talk about, but it's easiest to kind of talk through. So this is cloud configuration. It's standard cloud configuration. You can also use any of the other existing cloud config settings. It doesn't disable it or anything. It's just on top of it. And you can set things like the host name, introduce some users, turn K3s on, and really there's a lot you can do with Kairos. This is a very small snippet of the settings you can control, but you can declaratively define how do you want this device to behave or these devices to behave in your cloud configuration. And then the Kairos agent can just read that configuration and apply it to your device consistently. So let's talk about the immutable OS. The way we manage this is we kind of partition the boot drive in a special way. So we have our active and passive images. So that's going to be your root file system. That's that image you built initially. We'll get into why the active and passive and recovery. And then there's going to be the persistent partition. So that's where all of your application data is actually going, your persistent data is actually going to run. So if you think about like you're running an etcd node, all that etcd data actually needs to be persisted. We can't write to the immutable portion of the OS. So that's going to be, the persistent file system is layered on top of the immutable root. And then we can persist your application data. And then lastly, there is the OEM partition. This is a small, like 100 meg partition. It just contains the Kairos, that declarative configuration, persisted on disk, so that way we know what to do on startup, and you can kind of tweak Kairos that way. So why do we have the active and passive? So the active, passive, and recovery partitions make upgrades really reliable. So when you're coming in, you somehow, as a user, you want to trigger an upgrade from one OS version to another. Kairos agent will then go ahead and download the image from your container registry into the transition image. It's then going to copy active to passive and then transition to active, and then it'll reboot. So what this gets us, on the next boot, you're going to boot into your new active image. So OS updates, because the root file system is immutable, we don't have to wait for any installers to run. We don't have to rely on any registries being up. Everything that you need to run to set up this device is available to you right there. So we're going to boot up into the active partition. Now, let's say you roll out a change and something goes wrong, right? It fails to boot, you rolled it out to the wrong hardware, something like that. Kairos can actually detect these boot failures, and then it'll automatically fall back to the last version that you had. So that's what the passive image is for. So it'll automatically roll back the upgrade back to the passive image, and then you as the operator can kind of decide how you want to go about triggering a new upgrade or managing that. And then it's not depicted here, but there's also a recovery partition. So the recovery partition is the image that was initially used to install Kairos. That doesn't necessarily have to be what you use to run it. It's just one that we reliably know booted at least one time. So we persist it permanently, so that way in the event that both the active and passive fail for some reason, you have a bootable recovery image that can, take a more aggressive recovery by basically resetting the device and reprovisioning it. Obviously, that's not ideal, and you want to kind of stick with the active and passive, but in extreme situations, that could still save you from having to have an operator go into the field to recover a device. So with this core architecture, this enables us to do a lot of things in Kairos. So for example, like I mentioned, the configuration, you have that declarative configuration, but it doesn't necessarily have to be distributed as cloud configuration. By default, when Kairos starts up, it will generate a configuration. So it's going to generate a pairing token, start up with K3S, and then it'll display a QR code. You can then take that QR code and put it on other devices, and those devices will automatically join and form a cluster with that first device you booted up. Does anyone here do like home labs, running servers at home, anything like that? All right. Super nice for that. I actually use it myself, and it's really great for just because you can get up and going really fast with zero configuration. So the other option too is the web UI. When Kairos boots up, it'll give you, if you have the address of the node you're booting, you can sign into this UI and then enter your cloud configuration there and manipulate the OS right through the UI. And then so there's other ways there's a lot of ways you can do configuration. All of it is going to funnel back through the agent in that OEM directory. But these tools that we have, like the web UI and the QR code, are just built in to kind of help get up and running. Kairos also supports TPM disk encryption. So that can give an extra layer of security by ensuring that the user data is always encrypted. So in the event your device is compromised, they're not going to be able to decrypt any of your application data. You can optionally encrypt the whole OS if you wanted, but for performance reasons, it defaults to only encrypting user data when enabled. This also, in addition to just using TPM, Kairos supports processes where you can actually have remote authorization. So when a node boots up, it doesn't know how to unlock its own disk, and it has to call back to either like a central SaaS platform, or you could have it call to other peers, and it needs to authenticate with them to ensure that it's allowed to get its token from another machine. So that way, if a device is taken out of an environment, there's no way to decrypt it without bringing it back into that environment that you trust. Another one is our peer-to-peer networking. So this is super nice. You can actually start up a bunch of nodes. And if you think about traditionally deploying a Kubernetes cluster, first thing you're going to do is lay out your control plane nodes, get the control plane up, and then just spin up a bunch of workers. Kairos actually supports coordinating all of that for you. So you can just take a bunch of devices, provision them with your configuration and your OS image, and on startup, they'll discover each other on the network, and they are going to use a distributed ledger to actually perform leader election, figure out who's going to be the control plane, who's a member of this cluster, and they can form highly available Kubernetes clusters with etcd and everything with no intervention from the user. So it'll just wait until enough devices are online to go HA, and then it'll just start spinning up, and as new nodes come in, it can automatically join them into the cluster as well. Also, we have Aurora Boot. So this is an iPXE boot tool. You can configure a DHCP server to point to your instance of Aurora Boot. And this will distribute the net booting the operating system as well as a cloud configuration that you set. So if you're running like a virtualized environment and you want to leverage Kairos, you can just have all your VMs start up, connect the DHCP server, will tell them where to go for a boot, and then they'll all just automatically provision themselves with Kairos. And additionally, you could use the peer-to-peer networking, and then they would automatically form clusters as well once they're up and running. Lastly, we can also build these Kairos images. So when we talk about the flexibility of Kairos, when we talk about building an OS, installing your packages, installing all the drivers, all of that is done as a Docker file. So if you want to build a Kairos image, you literally would just pull from Kairos base, and then you can install whatever additional packages you need in your Docker file. It's a standard OCI image that it's produced. You can use Docker build to build it. And then that image can be directly installed onto these devices when they boot with Kairos, or you can use the OS builder, which is a Kubernetes controller, to build other artifacts such as ISOs, netboot artifacts, also cloud images as well if you want to do like AMIs or so on and so forth. So It's really simple to get up and running with Kairos, and it's really simple to generate these artifacts. That's kind of the factory aspect of Kairos, is building, even though it gives you the flexibility to pick whatever distribution you want, whatever Kubernetes you want, we also give you the tools to build those artifacts through Kairos. So it's really simple to get up and running with. So before we jump into a demo of all this, does anybody have any questions about what we've kind of covered so far? Or I'll just talk loud.
I can talk loud too. Thank you, though. So I was wondering, is each edge device a node in a cluster, or is it a cluster by itself?
As a single node cluster, or you can have them, by using that pairing token, you can tell them to form clusters. You can also give nodes different tokens and form multiple clusters on the same network. It's really up to you to how you configure it. When we talk about node, it's like a physical device that's going to boot the Linux operating system. And so they're all going to boot Kairos, and then they're going to look at that cloud configuration to figure out how to get Kubernetes set up and what to do with that.
Yeah, I have two questions regarding that. The QR code, talking about, I think of like worker nodes, adding worker nodes, and you said with the configuration. So the QR codes, could you add? You had another sensor at a region, then the QR code could add that to the particular node, or what does? I don't understand what the QR code is to particularly add. What are you adding with the QR code? Okay, great. And you mentioned POC like a restaurant. I could think like food trucks maybe is a use case, but that just doesn't make a lot of sense to me as an edge case. So could you explain that?
Some restaurants, you can think of like the simplest case, which is just the POS system. So the cash register that they're tapping your order in on. You could just provision those with Kairos, but some restaurants are actually getting more advanced with it, and they will have, excuse me, so they'll have all those POS systems. Then all of their equipment will actually have sensors on it trying to predict failures so that they don't have downtime. So like the fryer will have a Linux device running on it and recording, run operation and all that kind of stuff to predict failures. And then some of the really cool ones are doing, like they'll have a camera that watches the drive-through and then uses computer vision to determine how fast orders are going, all of that kind of stuff. So restaurants are getting real complicated with some of their tech. But when you think about these restaurants all across the country, something in, like here in Pasadena, they're probably gonna have a great internet connection and they could just call home to a cloud provider. But restaurants in more rural areas, they may not have reliable internet. They may be using satellite. So that's where you're going to get into the more disconnected cases and where your restaurant manager is going to be the one asked to replace hardware because you don't have engineers on site. I could go on all day about edge use cases with things like that, but Kairos is really trying to solve for that case of I have non-technical users and I have unpredictable environments. How do I make sure that we have a reliable product?
Yeah, I was going to jump in and point out that at KubeCon, I think this was almost 4 or 5 years ago, Chick-fil-A presented, and you'd be surprised how much tech is in fast food places. So the things they do, they all want to track cold chain, like did food ever reach a bad temperature, but they're tracking the fryer temperatures for quality. And a really cool thing they're doing on some of these is many younger people will only order through mobile apps. They'll come to the store to pick things up, but they also have sizable business in the drive-through. And people who are casual, where if they see a long line, they'll go to the next place on the street. And what they are doing is tracking the people with the mobile app coming inbound to the restaurant to pick up their order. When they're a block away, they'll tell them, don't go in the drive-through. We know you're here. Pull into a spot. They have cameras that will learn a person's car and have an employee run hot food out that didn't have to, didn't get delayed 20 minutes while they're in the drive-through. And I'm told that they can generate hundreds of thousands or millions of dollars a year of improved business by just accelerating that customer experience. So all of these places are going tech. In fact, it's too bad Cali Burger across the street is closed, but in prior years, they made burgers with robots. And this is their headquarter show place, but it appears to be closed. But they had robots flipping burgers in there.
Awesome. Yeah, so with that, we can go ahead and we can show you a demo here. So what this setup is, so we're going to be using vCenter with VMs, but we effectively have all these devices are on, think of it as just a flat network infrastructure. One of the devices is running a DHCP server as well as Aurora Boot. That one's already up and running. And then we're going to boot up a couple other devices. These have a blank disk attached to them, and they're just set up to do network boot, but they have no configuration on them. So, hold on, I'm going to try to find my cursor here so I can scrub. This is to run the Aurora Boot server. As you can see, it's just a Docker run of an image. You pass in the configuration. This configuration is going to say, here is my Docker image that has my operating system on it, as well as some basic cloud config. So there's that join token we talked about. We're going to enable K3S, those kinds of things. We can see here in the logs of the Aurora Boot, it's started up, it found its ISO, and it's ready to boot things. We're going to go ahead and start up those VMs. You can now see there's some activity of devices. They hit the DHCP server, ask where the boot server is, it points into Aurora Boot, and then they're going to start downloading the kernel and the initRD to boot. This here is a terminal of one of those nodes being provisioned. So it has, you can see these are just dmessage logs, system D is starting up. And now it's going to start getting into Kairos. And Kairos is going to, because our cloud configuration told it to automatically provision on the first disk that meets our parameters, it's going to begin provisioning and installing right away. So no intervention from the user. We just started the machine up on the network, and now it's already installing the OS so that it can boot independently. It's going to take a second here to copy all of that, and then we also have a couple of them running. You can see all of these are doing the installation automatically, no intervention. We're just opening the terminals to look at them. At this point, it looks like they're wrapping up the installation. They're saving their configuration to the OEM directory. They're going to continue finishing up the installation. All right, there we go. And so now they're going to start rebooting. At this point, they're booting from their own boot disk. You can see in the grub menu there, we have Kairos fallback, so that's that passive image, and then recovery. There's also some other nice ones in there. And then once these devices boot, they're now fully configured, and they're going to try to form a cluster. So once enough of them are up and running, we're going to go ahead and shell into one of them. And then through the Kairos agent, once we connect to it, we can ask the Kairos agent for the kube config for our cluster. So here we are SSHing into one of those nodes we just provisioned, and part of our cloud config was our own SSH key, so there's nothing to set up. We then can ask Kairos for the kube config for this cluster. Kairos then returns it, and then we're going to go ahead and download that and connect to it with K9s. And then without any intervention from us, you can see that we now have a multi-node, highly available cluster with 3 nodes of etcd, 2 workers, automatically provisioned. This is trying to leverage as many of the features as you want, but you could also do this installation with a USB stick, get these devices up, and then power them on later on the network. If you're buying bulk hardware, you could have your OEM manufacturer pre-provision the installed image, and then when they get on site, they can figure out what cluster to join in from there. Or you could have some basic user intervention where they enter, whatever information. Really, that's the advantage of Kairos, is it's highly configurable. So it's not opinionated about how to use Kairos. So all of these, everything funnels through the agent, but the agent's really flexible with how you use it. So with that, big things with Kairos are the immutable OS. It makes it reliable. It makes it consistent and reproducible. The OSs are distributed as container images, so it makes it easy to leverage existing container infrastructure that you have up and running, as well as easy way to package it. It's nothing proprietary. It's just a standard OCI image. We simplify Kubernetes provisioning and the OS lifecycle management, so those aren't two different pieces that you have to figure out how to manage. They're just joined together. P2P network for automatically kind of discovering and managing, discovering and coordinating deployments. These HA clusters, and then the cloud init and the declarative configuration makes it easy to roll these changes out and know what's being deployed in these sites. And then, of course, you can keep your OS, whatever Linux distro you're comfortable with or you're already running on. You can bring it into Kairos and just get up and running with that, so you don't have to try to migrate your OS in order to adopt Kairos. Kairos will just layer on top this functionality. And then if you want to take it a step further, Spectral Cloud offers Palette, which is our multi-cluster management platform. Palette is integrated with Kairos, so if you want, you could manage all of those clusters that are being provisioned. They can automatically connect back to Palette, and so you have a central management hub for distributing these upgrades. We also have pre-configured packages for Kairos clusters and how you want to set them up. And you can deploy with our packs. You can actually deploy your applications within the platform to manage all of these edge sites. So it's really great because with one click you can just go ahead and update thousands of clusters, and that's all it takes. So if you want to learn more about Kairos, please check us out on the Spectral Cloud community Slack in the Kairos channel. We also do office hours. You'll occasionally find me in there. If not, then someone else on the team. There's Matrix, and then if you want to get started with Kairos, go ahead and check us out on our GitHub org, Kairos-IO. You'll find all of these tools that I've mentioned in here to try them out.